In this video, we will discuss how to use the distributive property. Formally, the distributive property states, for all real numbers a, b, and c, c times the quantity a plus b equals ca plus cb. Now this seems like a fairly technical and possibly difficult to understand definition here, so we're not going to spend a lot of time on it right now. Instead, we're going to jump to some examples, and then by the end of this video, hopefully we'll be able to shed some light on exactly what all that means. But there is one thing that you should start to understand at this point, and that is that you use the distributive property when you're multiplying by a quantity of terms. Let's take a look at what that means. If we use this as our first example, 3 times the quantity x plus 2, we need to use the distributive property when you're multiplying by a quantity of terms. Why is the distributive property necessary? If you look at this example, you'll see why. If you go through the steps in the order of operations, step 1, substitute the given values in for the variables, you'll see that there's nothing you can do there. We don't have any given values for x. Step 2, change all subtraction to addition by adding the opposite. There is no subtraction. Step 3, do everything inside the grouping symbols. Here we do have grouping symbols. This means that before we can proceed according to the order of operations, we would need to be able to simplify x plus 2. But x plus 2 cannot be simplified because in order to add, you must have like terms. And x and 2 are not like terms. So without the distributive property, we would be stuck. There would be nothing more that we could do to this expression. The distributive property is applied to very specific situations, and you can use the distributive property when you're multiplying by a quantity of terms. That is when you can use the distributive property. So let's take a look. Let's see if we're multiplying by a quantity of terms here, and then we would be able to use this new distributive property. Is there any multiplication going on here? Because in order to use the distributive property, we must be multiplying by a quantity of terms. So are we multiplying? This 3 here there's no symbol between the 3 and the grouping symbols, so that means, whenever there's no symbol, that you're multiplying. So you could put a little times dot in there, so that you see that this is indeed 3 times the quantity x plus 2. So now we're multiplying 3. What are we multiplying 3 by? If we're multiplying 3 by a quantity of terms, then we'll be able to use the distributive property. Here we do have a quantity, and what's inside the quantity? Things being added. That's the definition of terms. So since we have that plus sign in there, we have things being added, we are multiplying by a quantity of terms, therefore we can apply the distributive property. And here's how the distributive property works. When you use the distributive property, you multiply the number or expression out here by every term inside the parentheses. So we begin by multiplying this expression, 3, by the first term, x. So we get 3 times x. Now this plus sign should come straight down, and then we multiply this quantity, or this expression, 3, by the next term inside the grouping symbols. So that's going to be 3 times 2. The distributive property allows you to get around the step that requires you to do what's inside the grouping symbols if you're multiplying by a quantity of terms. Now we can continue through the steps in the order of operations, because now the grouping symbols are gone, so we can move on to step 4, take all powers. There are none. Step 5, do all multiplication and division from left to right. Here is multiplication, 3 times x. 3 times x is 3x. Plus, and here's more multiplication, 3 times 2 is 6. That's all the multiplication we can do, so we move on to the last step, do all addition and subtraction from left to right. There is addition, but the only way that we can add is if we have like terms, and 3x and 6 are not like terms, so this is now in simplest form. The distributive property allows us to take an expression with parentheses in it, and if it meets this requirement, we can make it simpler by getting rid of those grouping symbols. Let's consider another example. Let's take x times the quantity y plus 5. Remember, you can use the distributive property when multiplying by a quantity of terms. So let's see if we meet this requirement here. Here, there is multiplication. I'm multiplying x by a quantity, and inside we have things being added. We have terms. So yes, we can use the distributive property, and when you use the distributive property, you distribute the expression out here, the x, to every term inside the parentheses. So this is going to be x times y, bring down the plus sign, x times 5. And then you continue simplifying. Now, you should, every time you're simplifying, go through the order of operations. Alright, so I got to the step where we're doing what's inside the grouping symbols. We weren't able to, but the distributive property allowed us to get around that step. So now we can do any multiplication. X times y we can't really do anything with, so that's just x times y still, plus x times 5. Now this is okay right here, but we usually will write any number, any coefficient in front of any variable here. So we're just going to change the order there from x times 5 to 5x. We can always change the order of multiplication by using the commutative property. So this would be in simplest form. This form right here is also mostly simple. This would be acceptable in most cases, but usually you want that coefficient first. Let's consider another example. This example involves fractions. But whenever you have a fraction in an expression, all the rules apply. There's nothing new. Apply the same rules that you know, and then apply your rules of fractions as well, which you should know as well. So it's just combining two different things. There's nothing new, really. So we're simplifying this expression. There's no given values for the variables. There's no subtraction to change to addition. But there are grouping symbols, but I can't add them. I can't do what's inside because they're not like terms. However, I am multiplying by a quantity of terms, so I can apply the distributive property. When I multiply this expression by the first term, I have to multiply this expression by all the terms in the parentheses. So when I multiply by the first term, it's going to be 1/2 times 4. Bring down the plus sign, it's plus. Multiply by the next term, 1/2 times 3x. Now that I've applied the distributive property, the parentheses are gone. I can continue through the order of operations. There are no exponents, but there is some multiplication I can do here. Here, I'm multiplying and I'm involving a fraction. Whenever I'm multiplying an expression that involves fractions, I should write everything as a fraction by putting it over 1. Here I can cancel any numerator with any denominator. You can cancel when you have factors, things being multiplied. Here, we're multiplying. 2 goes into itself once, and into 4 twice. This will leave me with 1 times 2, which is 2, over 1 times 1, which is 1, and we never have to write anything over 1. We never need that 1 in the denominator, because 2 over 1 is just 2. Plus, similar situation is going on here. I'm multiplying a fraction by an expression that's not a fraction, but we can write it as a fraction by putting it over 1. Here there's nothing to cancel, so I multiply straight across. 1 times 3x, well 1 times anything is itself, so that's just going to be 3x, over 2 times 1 is 2. I can't add these because this term has an x, so they're not like terms. So this is in simplest form. Let's take one more example. Let's consider 4 times the quantity 2 minus x plus y. Here we're simplifying, so we should go through the steps in the order of operations. Step 1, substitute the given values in for the variables. There are no given values, so we can't do that. Step 2, change all subtraction to addition by adding the opposite. There is subtraction, so we're going to go ahead and change that subtraction to addition by adding the opposite. Now, when we distribute, we have to multiply this expression out here by every single term inside the parentheses. And we can distribute because we're multiplying here by a quantity of terms. So when I distribute, I'm going to start by distributing to the first term. That's going to be 4 times 2. Now, once you start to get good at this, you can just skip and just say 4 times 2, and you can just write an 8 here. But for now, it's a good idea to start off writing every single step. So I've distributed to the first term. Bring down the plus sign. Distribute to the next term. This is 4 times the opposite of x. Bring down the plus sign because there's another term yet. So we distribute the 4 to the last term, that's 4 times y. Now notice that this one is slightly different than the last ones because this is a quantity of 3 terms, but we really didn't deal with it any differently. We just had to distribute the 4 3 different times this time. And now we continue to simplify. 4 times 2 is 8. 4 times the opposite of x, well, it's a positive times a negative, and positive times negative is negative, and 4 times x is 4x, plus 4 times y is 4y. There aren't any like terms to add together here for the last step in the order of operations. So this means that this simplifies to 8 plus negative 4x plus 4y. As promised, let's see if we can now consider what this definition actually means. The distributive property states that for all real numbers a, b, and c times the quantity a plus b equals ca plus cb. We can deal with this c times the quantity a plus b because we're multiplying by a quantity of terms. So what does the distributive property tell us to do? Distribute this expression to each term inside the parentheses. This is going to be c times a. Bring down the plus sign. This is going to be c times b. All that they did to get this equivalency was distribute. They just didn't show their arrows, they kind of took a shortcut there. But that's all that formal mathematical definition means. As you get into more advanced mathematics, you'll see things like this. Don't let it intimidate you. Look at what they're doing, see if you can figure out how they can get from this step to that step using either what they show you in the lesson or what you already know. In the case of the distributive property, there wasn't much to it.